Hello, I hope you are doing well. I'm also doing well too. So today, remember what I said. Because of time and also lack of equipment, I'm not going to be proving those proofs of what under Euclidean or geometry, but I'm going to give you tips on how you can tackle questions because I believe that tips are the ones that will make you to understand or try to do it to do some application under Euclidean geometry. So most people, maybe if a question comes and say prove if maybe A B C D, it is a what, a cyclic quad or what, most of you might not know where to start. So now I just want to give you a hint on where you should know where to start. So first of all, the first thing that is also common, I want to talk about the bisection. When we talk about bisection, remember, now we are talking about a line that bisects. It can bisect an angle into two equal angles, or maybe some line into two equal lines. So, for example, if you have line A and what and B, and you have another line, maybe here I can say C, which is parallel. Maybe I can say D. If they say that prove that uh, maybe CD bisect AB. If they say prove that CD bisect what AB, this is how to prove this. How to prove this? Here, you simply have to prove that what? If you show that AD, it is equals to what? To DB, then you can conclude and say, therefore, because this it is equals to this, then CD bisect what? AB. This is the kind of a kind of situation whereby a line bisected what? Another line. But in situations whereby you have maybe, let's say, an angle, you have maybe an angle, maybe let's say here, this is A, this is B, this is C, and you have a line in between. Maybe we call this what? D, and here maybe we can call C1 and C2. Let's say maybe they say prove that, this kind of question will come and say prove that DC bisects angle what? ACAB. So you know that what they're trying to say is that you must prove that what this angle, this line, it bisected what? The angle ACD. So for you to prove or to show, you have to do what? You have to prove that C1, angle C1 is the same as what? Angle C2. So if you can show that C1 it is equals to C2, then therefore you did what? You proved that what? uh, CD bisect what? Angle what? ACB. Then we are done with bisection. This is the only thing that you need to know about what? A bisection. Then for now, let's go to something. Let's go to something else. So when you are proving, always remember, you prove with properties of what? Of that particular thing. Now let's go to parallel. Parallel lines. If you are asked to prove parallel lines, the only thing that you're going to focus on are what? Are angles. How? First of all, you can prove you can prove corresponding angles. How can you do that? If maybe somewhere in your circle or where you have what? An F-shaped feature. This is what you need to do. If you prove that with this angle, it is the same as that. Maybe let's call this A1, or maybe let's just call it A, and let's call maybe this one B. If you go and show that what? Angle A, it is equals to what? to angle B, then you can simply conclude and say, therefore, let's say maybe, okay, let me just write here and say C, AC, and then maybe BD. They can ask you to prove that or AC, it is parallel to what? To BD. Then to prove that, if you simply show that or what? Angle A, it is equals to angle B, you can conclude and say, since these two are equal, then therefore AC, it is parallel to what? To BD. You give what? A reason. What could be the reason? This is going to be a converse of what? Of corresponding what? Angles. But this is not the only thing that you can prove. You can also prove what? Alternating angles. You can also prove alternating angles. Let me show you how to do it. You can also prove what? Alternating angles. Alternating angles, if you see a Z-shaped like shape, or as long as you have something like Z, and here you have A, and here you have B, and here maybe you have C, here you have D. If they say prove that AB is parallel to what? To CD. If they say prove that and you have this shape, here you need to prove what? You need to show that what? Angle B, this, it is equals to angle what? Angle C. If you show this, then definitely you can go and conclude and say what? AB, it is parallel to what? To CD. You give a reason. This is the converse of what? Converse of alternating what? Angles. That's what you show. And it only depends on the shape of the particular thing that you have been asked to prove. It only depends on the shape that it formed. And now, this is about alternating. Now let's show the other last part, of which it is co-interior. Co-interior angles. Co-interior, if you see a U-shaped, it can be F. Sometimes in F you can prove two of them. It can be A, B, C, D. And they say prove that AB is parallel to what? To CD. Then what you can show that this angle A, maybe we can call this, yeah, let's call this angle A. Yes, you can call C1 and C2 because you have two angles. So from there, if you can show that angle A plus angle C1 equals to 180 degrees, given that, or maybe you are given some angles. Sometimes you'll be given some angles, maybe 60, 70, x minus 90, x minus something. That's when you know that here you need to prove what? Co-interior. Then we know that by co-interior, angle A plus angle C1, it is equals to 80 only if what? Only if A, B, and C are what? Are parallel. Then therefore you'll give a reason and say what? This one, it is what? A converse of what? Co-interior what? Angles. So this is what you know. This is what you need to know when you are asked to prove what? Parallel. You can prove three features depending on what the information is given. That's why in most cases I always emphasize on what? On observing. Please be good with observation. As long as you are good with observation, you can learn this thing fast. If you are not good, you train yourself. You train yourself through what? Through practice. Then this is enough about what? About parallel lines. Now let's go another thing that you can be asked to prove. So let's say they say prove if maybe oh, what can I talk about? Okay, let's do this one. Cyclic quad, yes. Cyclic quad. Cyclic quad. Cyclic quad is something like this. where you have all the vertices intersecting the circle, 4 of them, and this is called concyclic. Then as long as these two are like this, as long as you find them on the vertices, here you can simply prove and say what? This is concyclic. You can say therefore A, B, C, D, it is what? Cyclic quad, because it's what? Concyclic. Concyclic is concyclic. So sometimes they don't even need to tell you whether that it is a cyclic quad or what. You just need to see, as long as you have 4 vertices and what intersecting the circle, you know that with this one it is a cyclic quad. So now let's go to a situation whereby they ask you to prove. They ask you to prove cyclic quad. How can you prove cyclic quad? The first thing, you can prove angles angles on the same segment. As long as you prove that the angles on the same segment are equal, then you can conclude and say, therefore, this one it is a cyclic quad. How? Angles on the same segment is something like this. As long as you have A, maybe B, C, D, as long as you prove that or this, let's say A1, A2, here B1, B2, C1, C2, D1, C2. As long as you prove that or A1, it is equals to what? To B2. Then you can conclude and say, therefore, A, B, C, D is what? Is a cyclic quad. Reason, you say converse of what? Angles on the same segment. Simple as that. Then you need to know, in order for you to prove cyclic quad, you need to prove what? Angles on the same segment. That's the first thing that you can also think of. Then the second thing, you can prove what? And also remember, here you can also prove what? You can prove A2, that it is also equals to what? To C2. This is still angles on the same what? Same segment. And also B1 equals to what? To D2. This is still what? Angles on the same segment. And also what? C1 equals to what? To D1. Then you know that this is what? As long as you prove one of these, 1, 2, 3, 4. As long as you prove one of them, then you know that this one it is what? Cyclic quad, angles on the same segment. Then we are fine with angle on the same segment. Now, the second thing that you can prove, you can prove that what? As long as you have a quad like this, A, B, C, D. So guys, if you show that your angle A plus angle D, it is equals to 180 degrees. Then this one, it is what? It is automatically, you can conclude it automatically and say what? A, B, C, D. You can conclude and say A, B, C, D is what? A cyclic quad. And you give a reason and say what? Converse of what? Of supplementary what? Angles. This one, it is a converse of what? Of supplementary what? Angles. We know that the opposite angles of what? Of cyclic quad are what? Are supplementary. Supplementary means what? They added up to what? Up to 180. This is something that you can also prove. So now we have 2 angles on the same segment, supplementary what? Angles. So now let's go and check the other thing that you can prove for cyclic quad. So the last thing that you can prove to cyclic quad is the exterior angle of what? Of the cyclic quad. So this is the situation whereby, let's say maybe you have A, B, C, D, and you have a line. As long as, let's call this one A, C2, C1, This one is ABC. As long as you can prove that was angle C2, it is equals to angle B, then you can conclude and say, therefore, A, B, C, D is what? It's a cyclic quad. You give a reason. What could be the reason? The reason is that what? This one is the converse of the exterior angle of what? Of a cyclic quad. Simple as that. You see? Then it's fine. Then now, everything about cyclic quad is fine. Now let's go and check something that you can also prove. Okay, you can also be asked to prove whether a line it is what? It is a diameter. Yes, they can also do that. And in order for you to do that, what is it that you need to do? You need to do what? To show this. In which theorem is the diameter included? The only theorem that I know that a diameter, and they talk about a diameter, it is the one that is subtended by a diameter. It is this kind of theorem. When you have a line like this, and they say A, B, C, as long as you prove that C, as long as when they say prove that or something, it is a diameter. If you prove, or maybe if you show that or angle C, it is what? It is 90 degrees. Then therefore you can conclude and say what? If you ask to show that or AB, it is a diameter, you can conclude and say therefore AB is what? Is a diameter. It's a diameter because C, angle C, it is equals to 90. This is a converse of what? Converse of what? Angle subtended by what? By a diameter. Simple as that. Angle subtended by what? By a diameter. Simple as that. And then, yeah, this is the only thing that you can do. There's only one way to prove that a what? A line, it is what? A diameter. Simple as that. You just prove that or what? You will be given something like a triangle. As long as you prove that or this one, it is 90, then you have proved that or this, it is what? A diameter. And another conclusion as well is that you can prove that our angle at the center is twice angle at the circumference. Because remember, at the center, maybe you're going to have a center somewhere here. As this is 1/8, it's not so. The angle at the center is twice angle at what? At the circumference, of which this is just going to be 90. So this is what you need to know about the diameter. Then now let's go to another thing to prove. So sometimes they can ask you to prove whether angle A, they can say prove that angle A it is equals to angle B. So this one, you will have to use all the other properties that you know until you get to what? To the answer. It's not so. And sometimes, yeah, this one I don't think that there is much to say about it. So as long as you can use other properties until you get to a point where by A it is equals to B, you can conclude, but you can't even say a converse. You will just conclude and say maybe it is equals to something that this other angle it is equals to that one. Okay, you can also be asked to prove a tangent. Yes, you can also be asked to prove whether something it is a tangent, a line it is a tangent. Yes, you can be asked this. Then to do this, remember, you'll be given a line like this, and you're gonna be given maybe a triangle inside, something like that. Yes. So as long as if they say prove that or AB, it is a tangent. Maybe here they say P, something like that. So as long as they say prove that or this, it is a tangent. What you need to do, as long as you show them that what, or this angle, it is equals to this. As long as you show them that or D, angle D, it is equals to what? Let's say C1 and C2. As long as you show them that angle D is equals to angle C2, then you can conclude and say, therefore, AB is what? Is a tangent. The reason why tan converse is a converse of what? Tan chord theorem. You know that for this to be equal to this, then this one needs to be what? A tangent. Then you prove that tan chord theorem, because in tan chord theorem, that's the only theorem that we talk about a tangent. So which means you go to what? You go to that tan chord theorem. Or you can still show that with angle C1, it is equals to what? To E. You can also say that. You can also show that for the same reason, tan chord theorem. Simple as that. I think that one is fine. So I don't know, maybe if there's something that I also left out, but sometimes they can still ask you to prove if this it is an what isosceles triangle. For isosceles triangle or equilateral triangle, yeah, they can still say prove that maybe A, B, C. They say triangle A, B, C is what? Equilateral. Equilateral triangle. Then to prove an equilateral triangle, you have three properties to use. It's not so. You can either prove that AB, it is equals to what? To AC, which is also equals to what? To BC. If you can prove that with this one, it is equals to that. You have proved that with what? It is equilateral triangle. And also, if you show, if you also show, if you show that with angle A, it is equals to angle B and also angle C, such that this is equals to what? To 60 degrees. You can also conclude and say what? Converse of what? Equilateral triangle. You can also do that. And if they ask you to prove an isosceles triangle, isosceles, if they say maybe A, B, C, they say prove that triangle ABC is isosceles. You also have to prove two properties. You said that you show them that A it is equals to what? AB it is equals to AC. Or it can be either way. It can be BC being equals to what? BC being equals to A. Yes. Or you show them that BC it is equals to what? To AC. So as long as there are two sides that are equal. And also, lastly, you can also show that maybe angle A, two angles are equal. Angle A it is equals to angle B, or maybe angle A equals to what? Angle C. Or angle C equals to what? Angle B. You can conclude and say what? Converse of what? Of isosceles what? Triangle. So guys, please, if I left out something, you will still tell me. Oh, the other thing that I think you can also be asked. This one is very, very important. Let me explain it. For grade 12, it's very, very important, this one. This one is very important. I'm just giving you tips, remember. If they say, show that triangle ABC, it is similar to what? Triangle maybe DEF. So here, what you need to know is that you need to show only, and worst part, sometimes this thing, it is always arranged. It is arranged. If they say this, just know that you must go and show that maybe angle A, it is equals to what? Angle D. Or maybe B, it is equals to what? To E. Or maybe C, it is equals to what? To F. So in most cases, angle A will be equals to this. And then the second one equals to what? To the second one. And the third one equals to what? To the third angle. But remember, in similarity, when you are proving, you only need to show two things. You need to show only two angles that are equal. And then the other one, you can just conclude and say what? Third angle of what? Of a triangle. As long as you see that two angles are what are equal from different triangles, you can conclude and say what? Third angle of what? Of a triangle. So this is what you need to know about similarity, of which in similarity, you can also apply what? Proportion. You can also use proportions. How do you use proportions? When you have AB like this, it's going to be AB. You will say it will either be over. You choose. It can be AB and you take, if you're taking AB here, you must also come and take what? DE. You use DE, you will say DE equals to, you find another thing as well, say AC. If you're using AC, you must also come and take what? DF here. It's not so. And also, if you are going to take BC over, you can also use what? EF. You equate it to something else. You equate it to something else. You can take also AB, of which is going to be the same as what? DE as well. So these things, they need to correspond. As long as you know this, then you will be fine. So if you found that maybe two angles are what? Are equal, and then you can just conclude the third angle. The reason when you say triangle ABC, it is similar to triangle DEF. The reason here you say what? Angle, angle, angle. This is the reason. But then if you are going to prove maybe with one common side, whereby you are proving with a side, or maybe you find that maybe two sides or what, that's when you conclude sometimes, but it will depend. It will depend. But then normally in grade 12, we use what? Angle, angle, angle. So this is what I think that you need to know about what? About Euclidean geometry, how you can tackle those applications. So guys, please do not forget to share, like, follow, subscribe. You can follow me on Facebook. You can go on and follow me as well on TikTok. I'm Romeo, and on TikTok I'm just Romeo. And you can also subscribe to my YouTube channel. Thank you.